Yeah, hi everyone. Today let's discuss about the paste bin system designing. I'll start with the functional requirements and after that I'll go to the capacity estimates and I'll finally explain the eye-level architecture of this paste bin. So coming to the functional requirements, basically paste bin is a website where the user can store any text content and it will generate an URL which will be used again to fetch that exact content. So the functional requirement is basically we will be uploading the text in a text editor from the Pastebin website, and after that we'll getting the URL, which will we again redirect the URL to that exact content. And this data links should have an expiry time, like it should be customized expiry time, like user can paste the content for 6 months or maybe 1 year at max. And we are restricting the data to 10 MB so that user can't exploit the functionality of the paste bin and he can update any anonymous or like some random file data to the paste bin. So we are because let's say like if they are storing some video or in the paste bin and they are just editing the text and pasting it, so it might take like 2 GB of normal video size. So uh, to avoid those exploiting behaviors, we are restricting it to the 10 MB. And coming to the non-functional requirements, we want the content to be durable. Like if the data should always be there, it shouldn't get lost once the user pastes the data, and it should be highly available. It should be accessible whenever the user wants the content. So let's say our server is down, it should still be available for the user to use it. We can handle by using multiple replicas that we'll be discussing in the high level architecture. And it should be low latency. There shouldn't be any latency lag once the user requests the paste, and it shouldn't take much more time. We should have a minimal SLA for that case. And paste link should not be guessable. This is an important requirement because uh, if the link can be easily generated, there might be say some data which is personal to someone or some content to some organization which shouldn't be exposed to other individuals. So we can have an access mechanism, but for now for this system design we are just taking it's not guessable. And coming to the capacity estimates, this is completely depending on the business requirements, but we are taking an assumption to come up with the design for now. Based on these assumptions, we are estimating there can be 100K pace per day, and 10 times of the read, 10 times of the paste. Uh, and coming to the reads, there can be multiple users who can be accessing the read request at a single time. So coming to the traffic, there will be 100K per day, and each day we can assume that there will be 100 seconds. It's 86,400 milliseconds, but on the overall approximation we are taking 100K seconds, which will be coming as 1 TPS, and the read API is 10 times of the pace, so it will be 10 TPS. So coming to the storage mechanism, here we are restricting it to 10 MB. So we are worst case we are assuming there will be 10 MB, which is given by the each user, 100K users. So here the estimation would be coming around 10 MB, which is like 10 power 6 bytes, and here K is 10 power 3, which would be around 3. So it will come around approximately 1 TB per day, which is very huge. And coming to the average case scenario, we are averaging it out. The every user average will be around 100 KB. So here this KB is 10 power 3, and this K is 10 power 3 again, which would be summing up around 10 power 6. And 10 power 6 will be approximately 1 GB. So 1 GB per day, and yeah, there is one more zero, so it would be 10 GB per day. This would be the our storage estimations for the content. So basically, we can use some kind of blob storage to store the text content, uh, which would be saving us a lot of cost. These are the estimates for the blob storage capacity. And coming to the schema, basically we needed two kinds of schema. One is to store the user details, which will be having the name, email, and other metadata related to that user. So this metadata also contains whatever the pastes done by that user. We will be storing them, and we are partitioning based on the ID. And there is another table which we needed. It is basically the paste ID, content link, which might be the S3 URL or blob storage URL, whatever is needed, and created time and expired date. So these are both are date parameters, and these are not so used databases. So coming to the database choice, we can pick SQL or NoSQL. There are no constraints, but I'll prefer NoSQL because of the scaling issue. So here there are 100K paste by an user. So there will be 100K records for the paste details each day, and user details won't be that many, and we don't have any ACID constraints, so we can easily go with the NoSQL database. Same for the paste details also. This preferring NoSQL will give us flexibility on scaling for the used data as well. And to add on why we are not using any database to store the content, so there is a size limit for each DB. Like in DynamoDB it would be 400 KB we can store a record. So here the content itself is 20 MB, 10 MB we are restricted the paste to 10 MB. So in MongoDB we have a document size can be stored up to 16 MB, which we can prefer to store the content. But if we want to scale in future, our text size we want to increase it to 40 MB, MongoDB won't be feasible. So which is one more reason why we are preferring the S3 and to store the content. And saving in DB will create an extra op anyway. Like we fetch the DB to get the S3 URL, and again we try to fetch the S3 URL and extract the text content. But to avoid any future scaling, future requirements, we'll go with the blob storages. And we can also do an hybrid approach. Like let's say if some content whose size is less than 5 MB, or which can be stored in the DB, and greater than that we can store in S3. But it will also be an overhead, like to having multiple DBs where we are storing our data. So we'll prefer using blob storage for now. And coming to the API requirements, we have two APIs mostly used. Like one is to add the paste in to get the paste. We can have a third URL which is like delete paste, but coming to the for that delete paste, we won't be exposing it to the user as per the requirements. If needed we can expose in future. And coming to the parameters, API dev key is the API developer key of a registered account. This will be used to allocate the throttles, basically the rate limiting for that user. And the paste data, it's the pure string like textual data which will be given by the user. And custom URL is an optional parameter. The user can give the custom URL which he needs wants to redirect, but this, if that same URL is already having any content, will restrict him. And the username of that particular user and the paste name. Coming to the get paste, you can only give that paste key which is written by the add paste URL. And coming to the high level architecture, we have the client will be invoking the gateway, API gateway or load balancer, which will be using any of the load balancer algorithms like round robin, and which will pick the write instance or read instance based on the URL request. And here to store the API, we can either prefer a microservice or we can have a Lambda or EC2 instances. So to for having the multiple replicas, and like here read is more heavy. It's a read heavy system, so we want to have more read replicas than write. And so what basically this read does is like it will go to the cache, and if the same key is present, it will get the S3 URL and it will fetch the content from there, or else it will go to the DB. So as it is a read heavy, we don't want to trouble more on the DB. We don't want to invoke more DB instances. So we are using a Redis cache here to store the paste keys, and we'll fetch the S3 URLs. It will be a quick, and the write basically does the uh, content, create the record in the DB and paste the content in the S3. And here for caching we can use LRU or LFU eviction policies. Uh, Basically we can prefer based on the data driven, we can have metrics based on which we can take the data driven. And uh, so we have like few questions like choosing the length of the URL. So what will be the key, paste key, which we'll be giving to the user? So it we can select a short key, or there is no restriction on the length of the key, but it is highly preferred to have a short key. Though we can choose base 64 two characters, because in base 62 we have like all the alphabets and the numerics, which would be accounting to 64. And in 6 we are not using 64 because in 64 we will be having plus and slash character, which are basically uh, which will not be helping us in redirecting the URL. We will be having a trouble to redirect the URL using these characters, so we are avoiding these two characters, and we will just encode whatever the key in base 62 encoder. And how to create the keys, like we can have here I proposed like three strategies. One, to let the DB create the keys, but like using an auto increment. Most of the DB support auto increment, and if whenever a new record is added, the increment will be there. But this will make the keys very predictable. Like after 1, 2, 3, 4, it will be easily paste keys predictable, and other users can just base 62 encode that key and get the URL. So to avoid that, we can also use a random key by generating a random function, and we'll check the whether that key is there, and by using a unique constraint in the DB it will be easier. But there are collisions after after some keys which were what pasted, so the retries will increase after some scaling. So there will be a latency. If there is a collision, we again regenerate a random key and we check in the DB if that record is present or not, and which will increase the latency, and we can't met the SLAs in that scenario. So one other strategy which we can use is creating a new service, uh, key generation service, which will be distributed. It can be of master slave architecture or master master architecture, but it's basically because if one key generation service is done, we can have other key generation service which will be doing the parallel threading. And on the if one thread can generate the multiple keys and one can be stored. And the same distributed key generation is also used in Twitter while generating the tweet IDs. So this is a tested idea on generating the key generations. And coming to the key size, we can have like or 8 characters of key size. So here basically we have 62 characters. So we will be ending up with 62 power 8 number of paste keys, which will be around a billion, or more than a billion. So we won't be ending up with most of the collisions, but having a separate database for generating the keys, it will be beneficial, because whenever we want to delete the paste keys also, we'll put those deleted keys in the database, and we can reuse those keys as well. And for the uh, key generation service, we are having a separate memcache. So here the memcache won't be taking that much, because here each key is of 8 characters, which would be coming around 8 bytes, and 8 bytes into uh, 62 power 8, which would be coming around, it's a billion keys, so which would be coming around roughly, I'm taking like 10 TB. So this is very less compared to the compared to the Redis size. So we can prefer this. And coming to the cleanups async, like we can have a cron job schedule every hour, which will go to the DB and check all the expired paste and which will remove from the paste, and it will also remove the S3 data, as so it would be, we will be saving a lot of money on removing the S3 links. And also we will write a soft delete to whenever the basically works like whenever user wants to perform a read based on the expired paste link. So user request for the read, and in the read we check the expired time. If it's expired, then we just make a flag like is deleted to true. It we won't be removing the exact record from the DB. We are just updating the flag, and we will be returning to the client that the data is expired. And after some 1 hour or the whenever the async triggers, it will clean up the data from the DB and S3. So yeah, that's about it. I have covered all the major components which will be needed for the paste bin design. Yeah, thank you.